Hi, everybody. I'm Caitlin. I'm the CTO and co-founder of Hex. You probably saw a little bit about us earlier in the summit. We were in the keynote, and maybe there's a few other sessions that you've been to. But what I'm really excited to talk to you about today is to show you some of the really cool features that we've been able to build in partnership with the Snowflake team, and also pull back the curtain a little bit and show you how we actually built those features under the hood. Go. There we go. OK, pointed at the computer. Yeah, it's a picture of me. Before I go into the features, I want to give you a little bit of background about Hex, about my journey as a co-founder. 4 years ago, when we started the company, really what we were seeing, and many of you are probably experienced this or are even still experiencing this today, is that there was a lot of brokenness in data science and data analytics workflows. With the advent of the cloud and a lot more technical workflows, a lot of people were using code and using the power of code to do deeper and more complex analysis. But it was really hard to get started with code. Maybe you're a SQL expert, but Python is something that you're not familiar with, or even maybe you just weren't familiar with the data model that you're working with, and it's just hard to understand that out of the box. Many people back then, when we were starting the company, were working in local notebooks or hosted notebooks that were still resource-bound in the same way that local Jupyter notebooks were, and really couldn't take advantage of the new data scale that cloud data warehouses were bringing to analytics. What's worse, you often had to choose your tool not based on what you were trying to accomplish, but based on the language that you wanted to write in. Maybe you were writing SQL and you had to go over to a SQL Scratchpad, or maybe you wanted to write in Python and you were forced into a Jupyter notebook, or even if you wanted to do some visual drill down, visual pivoting, or visualizations, and then you would go over into your BI tool, your Excel spreadsheet. This led to workflows that were strung across many, many different tools and were really brittle, really painful, very hard to iterate on. And lastly, with the cloud data warehouses, people invested a lot of time in the security and the governance and the privacy around their data and their data model. But as soon as you wire up a local notebook to that and you start downloading data out of the cloud, all of those governance principles kind of go out the window. So we were seeing all of this, and really we started the company to try to make data science and data analytics workflows as smooth and delightful and seamless as we possibly could. So to show you some of the stuff that we've actually built on top of Snowflake in order to enable this, I'm going to start with a little demo. Some of these things you probably have already seen. Some of these things might be new to this session, but I just wanted to recap some of the features that we're going to be talking about. So if you haven't seen it yet, this is a Hex workbook here. We're going to start by using Hex Magic, which is our AI code assist. We're going to write a pretty straightforward query here. We're going to look for transactions in our retail data set that involve computers. And as you can see, kind of running this out of the gate, Hex Magic does a decent job. Actually, this SQL query is totally correct. It gets the right table. It gets the like computers correct. We're going to narrow it down a little bit. We don't need all of the columns in the table. But when we go ahead and run this is a transaction data set. It's pretty large. And doing a really simple query like this is going to bring back a lot of data. And in many previous iterations of notebooks where you're running in a Python kernel, this would just crash the notebook. But in Hex, we've built this thing called query mode, which, as you can see, brings back only a preview. Now, with a preview, you can't do much. But what we've built into Hex is the ability to treat that as if it were a full data set. And so you can just natively write another SQL query on top of that variable as if it were a data set. And what we are doing is we're intelligently combining these two and running them all on the underlying data warehouse, which you can see, in fact, is the case here. So that's for SQL. And you can we call this chain SQL, and so you can do a sequence of SQL operations on top of each other, all in the data warehouse. But what if you want to do Python? And this is where Snowpark really shines. So instead of returning a SQL query here, I'm actually going to turn this into a Snowpark data frame. And as you can see down at the bottom here, this is, in fact, a Snowpark data frame. We're going to rename it just to make it a little bit easier to reference. And then we're going to run some Snowpark code on top of this. Awesome. So that just works as you would expect. But what we've spent a fair amount of time working on with the Snowpark team and in Hex is making it so that this Snowpark data frame can be used as seamlessly as any local data in Hex that you can imagine. So this is our native table display view. This is our native chart view. All of these are referencing the Snowpark data frame, not actually any local data. And then one of the coolest things that we've done is this Snowpark data frame, you can treat it like a table. You can write SQL against this Snowpark data frame in Hex. And what this does, it allows you to move seamlessly back and forth between all of these different modes of analytics, all in one workflow. And you can really pick the language or technology that is right for whatever you're trying to do. And then lastly, you saw this demo during Summit, but all of this is in fact running inside Snowpark Container Services, which I'll talk about how cool that is in a second. So we just did the demo. I'm going to give a little bit of background into how Hex as a notebook works. It's not exactly the same as a lot of traditional notebooks, and there's some cool reasons for that. And then what I'm going to do is I'm going to basically give you 4 little lightning talks about these different features. And I'm happy to answer any questions or go into more detail about any of those after the talk. So a bit of a preview. How does Hex work? So a lot of you here have probably used notebooks like Jupyter or Colab or any sort of traditional notebook tool. And many of you have probably also seen the famous talk, "I don't like notebooks." One of the big issues that is brought up here and sort of across the board in notebooks is what we refer to internally as the state problem. Notebook cells can be run out of order, and they can also be run without rerunning dependent cells. And as a result, the state of the data in your kernel can be out of sync with what you're seeing in the code. And if you work frequently with notebooks, I'm sure we've all had the experience of restarting the kernel, running the notebook top to bottom, and finding out that it is in fact completely broken because there was a bunch of hidden state. I see some nods. There's a bunch of hidden state that we didn't know about. The way Hex fixed this problem, and this is one of the first things that we built in this sort of journey of streamlining data science workflows, is when you're typing, as you're writing code, in the background, we are automatically parsing that code and pulling out dependencies between the cells. So if you're reusing variables in various different cells, if you're building SQL on top of each other, we know that behind the scenes. And we do it automatically without you having to run anything. And so what we're doing under the hood is we're building up a graph, a directed acyclic graph, a DAG, of all of the cells in the notebook. And we originally did this to fix this state problem, which means when you run a cell, we automatically rerun all of the dependent stale cells that you would have needed to run in order for your state to be consistent. This also has performance benefits, so Hex notebooks and Hex apps are highly interactive. This means that we can pick out exactly the cells that need to be rerun and not have to rerun the whole thing. But it really basically, the initial motivation for this was to make sure that the state was always in sync with the code. However, it turns out having this DAG structure really, really helpful for a bunch of the features that I'm about to show you. Oh, yeah, if you're interested in hearing more about how we do this, I gave a talk last year about this. You can look it up on YouTube from Data Council. It's actually pretty interesting. OK, cool. So the first thing I want to talk about in terms of the features that we've built. Now, there's been a lot of AI at the Summit. I do AI, you do AI, we all do AI now. But one of the differences with this talk that I wanted to go into is how do we actually build an AI system for data science and for data science work. So I'll tell you a little bit about Hex Magic, which is our code assistant that we've built into the notebook. It's important as a co-founder and as sort of like a product leader to always be rooting things in problems that we're trying to solve. I know AI is super buzzy right now, but there are real difficulties that we're trying to fix in terms of the user experience, and this is the biggest one. It's really hard to drop into an empty notebook and say, okay, how do I get started? What do I actually want to get out of this? Maybe I'm like not a SQL expert and I really have trouble with window functions. Maybe I am a SQL expert, but I'm new to this part of the data model and I'm not quite sure which tables to use. This can be a pretty high barrier to entry for anyone who's not a deep domain expert maybe on the data team, for example. Well, how do we get around this, or how do we improve this workflow? Well, we allow people to ask natural language questions of their data and produce the code that they can then run or edit themselves. And Hex Magic has gotten to the point where we've put enough into this that we can get some pretty complicated, sophisticated SQL queries out of this. But this doesn't work necessarily out of the box with a language model. So why not? Something like GPT. I'm pretty sure everybody here has probably asked GPT to write some code ChatGPT to write some code for them at this point. It's actually really good at writing syntactically correct SQL. What it is not good at is knowing about your data. ChatGPT was trained on the public internet. I hope your data is not on the public internet and is not in the ChatGPT model. But how do we bridge this gap? Because it's really important, and actually ChatGPT, it makes guesses at table names, but if your schema is anything like our schema, sometimes the correct table names are actually pretty obscure and hex specific. So if you're familiar with language models, you know you can put stuff in the prompt. The problem with this approach is that for small prompts, you can't get the whole schema in, and for large prompts, it's actually worse, not better, because you're giving the model a bunch of irrelevant schemas to actually look at. It actually hallucinates more when we try to feed it in the entire schema, which can be quite large. So the first problem we had to solve here was we want to provide it schema information so that the SQL is correct. How do we do it, give it only the relevant schemas? Well, actually, it turns out we have this handy tool here, which is the DAG. We can look at the DAG to produce relevant context for the language model prompt that we're passing through. We had to do a lot of different stuff across the product to get this language model to work transparently. So I'm just going to focus on what we're doing for SQL right now. This is actually how we're building the SQL prompt. So we're giving it the dialect, some basic other facts about what we're trying to do. If you're referencing a schema directly in SQL, we'll pass it that schema. We'll also do a bit of a fuzzy search around that schema in case you misspelled something to try to pull those schemas in for GPT. But where this really becomes super powerful, let's say in that chain SQL example, you've already run a SQL query, and we're running another SQL query on top of that result. Well, it turns out we actually have a pretty darn good idea of what that schema is going to be and what columns you might be referencing. And we know that because we know the DAG, and we know all of the upstream cells and all of the relevant context for what this cell before you've even typed a single character, and we can start providing that to GPT. We can also include other types of context too in the DAG. So maybe upstream cells aren't SQL cells, so they aren't directly referencing schemas, but they do have a lot of semantic information that you can mine from them to try to suggest which might be the most relevant schemas in the overall schema to include in the prompt. So to put it all together here, this is actually the Hex Magic architecture. We just talked about prompt construction. We're pulling in things like variable names. We'll pull in some metadata from Snowflake. We don't actually train on any data or anything like that. And then we pull in context from the DAG and put that all into the prompt. There's two other interesting pieces to what we've built in this architecture. One is these prompt templates. So Hex has a lot of different magic tasks that are all similar but not exactly the same. So maybe you want to generate new code, or maybe you want to edit old code. Or we even have one of my favorite features. If your code returns an error, there's a button that just says fix. And we basically ask the model to fix the code, and it actually works pretty well. All of those are overlapping but not exactly the same. So you can think of the prompt templates as basically Lego blocks that we use to build up the overall prompt, but reuse some of the pieces of logic. And then the last thing we do is we pass it through what we call a conformer, which is basically just an abstraction layer between all of the different language models, which means that we can run it on OpenAI, we can run it on Anthropic, or in the context of this conference and many of you, we can run it in an LLM running in Snowpark container services. OK, so that's magic. That's how we get started. But let's talk about the actual deep part of the analysis, the iterative part of the analysis. And one thing that people really love about notebooks is this ability to do sort of a sequence of steps, examine the outputs at each steps, and kind of iterate from there. But in traditional notebook workflows, that doesn't scale. In order to do that, you have to pull all of the data that you're working with down into the notebook, into the kernel itself, which is typically quite restrictive in terms of what it's able to do. So how do we enable a workflow like this, where we can have this sequence of steps and we can do this iteration, but still take advantage of the scale of the cloud data warehouse? Well, so yeah, let's just a concrete example here. Maybe you have one cell that returns a bunch of data. We then aggregate it down into something really small, and typically it would fail right about here. Now you might say, hey, I'm a sophisticated SQL analyst. I know a lot about SQL. I can just write a common table expression to combine those queries and run them all on the underlying data warehouse. And you would be right. CTEs are a really, really powerful tool for being able to take a bunch of SQL queries, combine them together, and then run them atomically. However, they're really hard to reason about. They're very error-prone. And if we're talking about enabling more people to use code and more people to use these languages in order to ask questions of data, they're even less approachable than just writing a single SQL query. But it turns out they're actually a really useful tool. And they're a really useful tool because we can build it for you automatically, again, using the DAG that we've built in terms of understanding the underlying dependencies between SQL cells. So in this example that I showed, What we do here is we take that big query, we wrap it in a limit 100 or 10 or whatever, so that you're seeing a preview, but you're not necessarily getting the whole data set. And then for the second query, behind the scenes, we automatically construct the CTE for you. So you know debugging involved, we just build it behind the scenes, and we run it on the underlying data warehouse. So now, all of your SQL compute is running on the underlying data warehouse, but you can still kind of do this workflow where you can see the results, you can build SQL queries on top of each other, and build from there. That covers SQL, but what if you wanted to do Python? I know I made a big deal earlier about being able to move between different languages. And the reality is, most tools kind of force you to pick a lane. It's like, OK, I'm going to be doing this in SQL. I'm going to be doing this in Python. But that can be really painful because some things are really nice to do in Python, and other things are really nice to do in SQL. Like, I don't know if any of you have ever run a linear regression in SQL. Like, in Python, it's 2 lines. And in SQL, it's hundreds of lines. Very, very challenging. So wouldn't it be great to be able to do all of these things together? And one of the earliest things we built at Hex is, yes, in fact, we built the ability to move back and forth between these 2 languages. And the first place that we did it was we did it locally. So basically, we used the pandas data frame as a foundation data set. And then, so whenever you would write a SQL query, it would turn it into a data frame. And then going back the other direction, we took advantage of DuckDB, which allows you to natively write SQL on top of the data frame object. This does have some limitations, though. One is that you're writing Snowflake SQL in some cases, DuckDB SQL in other cases. It can get kind of annoying. You have to reason about which data set is which type. But more importantly, as I was just talking about in the last section, all of this data, in order to do this, has to fit in memory. DuckDB is local in memory, and that has a lot of restrictions in terms of the scale of the data that you're able to work with. And for a while, that was pretty much all you could do, until we had Snowpark. And we were very excited about Snowpark, and we've been working really closely with the Snowpark team to make this workflow work, which is basically, instead of pandas as the interchange format, now we're using Snowpark data frames as the interchange format. And so what this means is that in Hex, you can natively run a SQL query, we'll create a Snowpark data frame, and obviously, you can do Snowpark on that, but you can also treat that Snowpark data frame as if it was a table, and you can write SQL against it. Or you can use any of Hex's built-in visualization cells and treat it exactly as if it were a pandas data frame in memory. So how does this work? There's a lot of moving pieces here and a lot of interconnections we had to build. But the big one is moving back and forth between Python and SQL. And one direction here is pretty straightforward. If you have a SQL query, Snowpark natively supports this behind the scenes. We wrap the SQL in a session.sql, and voila, you get a Snowpark data frame. The more interesting one is going back the other direction. So how do we allow you to write SQL on top of a Snowpark data frame? Well, here, again, we're actually using our DAG structure. What we're doing is we're looking for references. So Snowpark data frames that are referenced in SQL queries. And we don't do this for every data frame because there might be a lot of them. But if they're referenced in a SQL query, what we will do is we will automatically create a temp table using Snowpark's cache results under the hood. And it's only local to your Snowflake session. So you're not like cluttering up your data warehouse or anything like that. But then we can rewrite the query behind the scenes to reference that temp table and run the SQL completely transparently as if you were just running that SQL on top of that data frame. So at this point, we've got everything in Snowflake, right? We've got our Python in Snowflake, we've got our SQL in Snowflake, we've got our magic in Snowflake. Well, it's not entirely true. It's not entirely true because at the end of the day, Hex is running on our own infrastructure, and we need some of that. Maybe we're just rendering a table that has data in it. And while we've taken a very security-first approach at Hex, we've spent a lot of time on our infrastructure minimizing the data that we need, making sure that it's all secure and well-governed. At the end of the day, that's another surface area that people have to manage in terms of data governance. And especially when you've put a lot of work into making that investment in the data warehouse, this can be just a lot of effort, a lot of things to think about in addition to that. And knowing this was why we were really early and really excited to jump on the Snowpark Container Services train. And so you probably saw this a lot, the keynotes, if you were in there. And I think they actually undersold this a little bit in the keynotes because they were like, oh, you can run Docker containers on Snowpark Container Services. But actually, turns out, you can also run this on Snowpark Container Services. this is the Hex architecture right here. We're running on Kubernetes. We have a bunch of different services. Some of these are dynamic. We scale them up and we scale them down. If you look in there, there's some networking. There's a lot of stuff going on here. And the reason we designed it this way was so that we could do, basically what we do is we have a lot of parallel Hex instances running, and we run them in isolated AWS accounts. So one is our multi-tenant account. If you go to hex.tech and sign up, this is where you'll land. But we knew that our enterprise customers were going to want more isolation and more security than that. So we also have single tenants that run in isolated AWS accounts. But this is awesome, actually, because it turns out that we can just take our architecture and we can take our deploy pipelines, and then we can, just like we were sort of copying them across different AWS accounts, with a lot of partnership with the Snowpark Containers Services team, and I can't credit them enough for how much work they've put into this, we are also now able to take that entire architecture and copy it and deploy it into a native app stack inside a Snowflake account. So just to kind of wrap up here, like I said, as the founders of Hex and as the builders of a data science, data analytics workspace, really the thing that we are laser focused on is making these workflows as seamless and as smooth and as delightful as we possibly can. And in the last 18 months that we've been working with Snowflake, we've gotten so much farther and so much beyond what we could have wildly imagined when we set out to do this. We've built Magic, we've built Code Assist, we've made it so that you can run all of your queries directly on the data warehouse, we've made it so that you can move back and forth between the different technologies, and none of it is actually leaving the secure data perimeter. I'd be remiss if I didn't shout out the teams that worked on this. They're all awesome, they're incredible. It's been such a joy to work with them, and I'm so proud of what we've been able to build together. So that's it, basically. That's the talk. I know I went through these pretty fast. It's a pretty big overview of the stuff that we've built. I'm going to be at the booth after this if you want to ask me any questions. We also have a lot of lovely other Hexans who are happy to help you over there as well. So thank you, everybody.